This is a demo about the FRINX UniConfig framework. The setup has 3 devices connected to FRINX ODL running UniConfig. And we have a Cisco classic iOS device, an XR device, and a Huawei running VRP 8. We run a GNS3 instance and a virtual Huawei instance. Here you see FRINX ODL. We have to install a couple of features here. CLI, the CLI translation units, the UniConfig manager, etc. And then we'll also turn on logging. Well, that's all you have to do in the FRINX Carafe environment. Then we have the 3 CLI windows here, the 3 devices. This is the Huawei device. Let's have a look what type of device that is. Yep, we say that's the platform information. And we'll have a look at the IP interface configuration. All right, next device is the Cisco iOS device. It's a classic iOS device, does not support any rollback, no rollback capabilities supported out of the box. And finally, the last device here is an iOS XR device, typically found on platforms like ASR9K and similar. In the next step, we're going to show you how to mount a device in ODL. We have a collection of API calls in Postman. Those Postman collections can be downloaded from our webpage. They are available to every release that we make. And here you show an example. We show an example for mounting an iOS device. There's a couple of parameters: username, password, IP address, obviously, and also what type of device we're going to connect to. That's needed for CLI devices. For netconf devices, obviously, the schemas are being downloaded from the device if the device is supported. Or we can also push them and prescribe which schemas the device has to use. So what you see here is the initial mounting and the initial reconciliation. So we kind of connect to the device and we run through the configuration and reconcile from the device, meaning we read all the parts of the configuration that we understand, and then we convert that into OpenConfig format and store it in our data store. So here, the mount operation has succeeded. These devices show as mounted and or as connected, and that means that they've been successfully reconciled and mounted to ODL. From now on, you can use them, you can write to them, read from them, and so on. This is an example for a netconf device, a little bit fewer parameters, mostly netconf port and IP address, and also credentials. All right, this shows you the capabilities that these devices have. And each device has a varying range of capabilities, either expressed through the translation units that are mounted with that device, or through the actual schemas that are downloaded from the device if they're mounted via netconf. In this step, we want to show you how you can verify that the devices are mounted successfully and that the whole configuration has been loaded into ODL, and how that is expressed through OpenConfig models. Let's have a look at the Huawei router. Here we see the OpenConfig representation of the Huawei router. And in this part of the configuration, we see the BGP statements, we see the address families, we see the neighbor statements. Let's have a look how this actually looks on the device. On the device itself, the configuration is displayed here. And we see the global BGP configuration with the router ID, address family unicast, and address family VPN v4. So we see the same neighbor statements again. So we see those. We see this is the same configuration represented in a different data model format. All right. These are the interfaces. Let's have a look on the interfaces. All right, here we go. There's one interface with an IP address on it. Next one is the XE router, iOS XE router. We see a handful of interfaces, 3 gig and 1 fast Ethernet. And again, this is the representation in OpenConfig here. So we've read the configuration from the router and transformed it into OpenConfig format. 1 is up, 3 are down. In the next step, we're going to configure the global BGP configuration. On the Huawei device, that is already there. We've already put that on previously on XE. Let's have a look what's on there. Oh, there's nothing. On XR, let's have a look if there's any BGP configured. Nope, there is not. In the next step, we're going to apply those global BGP configurations to those 2 devices, XE as well as XR. So here we're going to push this directly into the intent data store, the config data store, and this has the whole snippet for the BGP configuration in the body of the put call. So we push that, we come back with a 200 OK, goes directly into the data store, goes not yet to the device. Currently we've pushed it into the intent data store, the config data store, and not yet into the devices themselves. So we are preparing our desired configuration that we would like the network to assume in the next step. All right, so here we create a diff, and we have a look between the config and the operational data store. And what we see is the configuration differences. And here we see all the pieces of BGP configuration that we want to send to those 2 devices. So this is an important step where we look at the differences between the operational state and the config state. And this allows us then in the next step to go and commit. Here's one more step in between before we actually push this to the devices. We want to have a look how that transforms into CLI. This is a dry run commit that we've just shown you here, and this shows you all the different little configuration snippets that we will execute in the next step once we hit commit. So let's do that. Hit the commit, and it's going to take a little while. We're going to go to the devices. We're going to apply the BGP configuration on XE and iOS XR. In iOS XR, we're going to use netconf. In iOS XE, we're going to use the CLI interface. If we have a look at the log, we see exactly what's happening between the devices. We see what's getting pushed. And if you go back, we see that we have a complete message. That means the devices have been successfully configured with the global BGP configuration. So proof here on both devices, XE and XR, global BGP is configured. All right, next step is the layer 3 VPN instance. Let's have a look again at the BGP configuration. What's on there? Here we're going to create a verb with the name ABCD. And we're going to apply that to the interface. And then we're going to create a BGP peer under that verb. So all the information that you need to get that configured, all the information is passed in OpenConfig format and then is applied in either CLI or netconf format to the actual devices. Community lists, prefix sets. Right, and here the point is that this looks exactly like the other one, like the body of the other message, with the difference of the interface names the rest is completely the same, and this transforms into two very different configuration snippets. One actually XML based for netconf, the other one CLI based. All right, we see the address families, we see the neighbors under those worfs. Okay, so we pushed it in config data store, kind of created the intent. Now let's look at the diffs. We compare config data store and operational data store. Let's have a look at what those diffs are. We can see we've created these worfs, we've created these configuration snippets, and this is what we've intended. This is what we intend to push to the device for iOS XE, Huawei, and iOS XR. All right, so we do a dry run to see for the CLI devices how this looks like. We see this for the Huawei as well as for the Cisco iOS devices. Looking pretty similar there. All right. And then we hit commit and push this to the devices. And now we have a look at the log. With the command log tail, we can see exactly what's going on, what's being pushed to the devices. And we're going to following this here. Once this is done, we will get a response back via Postman that this is executed successfully and all the configurations have been applied. Okay, so here you see the different config snippets that have been applied. You see the netconf statements, all the information that you need for an audit trail, for example, to make sure that you know what's been going into the device, who has configured what on the device. We can push this to Elasticsearch or any other, Log4j destination, and this can become completely searchable and retrievable through that. All right, here you see the new WRF that has been created on the BGP. We have the VPN instance ABCD that has been newly configured and with neighbors in there. Same for iOS XE, the new neighbors, the route targets, import, export, it's all there. And again, let's have a look at XR. And again, it's there in the CLI germane to iOS XR. Okay, now let's have a look at the rollback capabilities. We want to demonstrate that if we make a mistake in a configuration, that FRINX ODL has the capability to reverse a transaction that it has made on multiple devices and roll back actions that it has taken on certain devices. A specific change that we are making here is on one of the devices, we are changing the global BGP AS number into a number that is not actually configured on the device. And that should allow us to kind of create an error when we try to apply that configuration. So here, instead of AS100 for a global BGP on Huawei, we are pushing towards 101, which doesn't exist and should error out. So we deliberately, include a mistake here to show you a transaction over 3 devices, how that can be rolled back in case one device does not succeed. All right, so we're going to have a look at the delta again, or at the diff between the intended state and the operational state. Here we have an error here, but we're going to apply it anyway. So let's try to apply this configuration to all 3 devices. So what's going to happen is the configuration will be applied to iOS XE, iOS XR, it will make an attempt, or FRINX UniConfig will make an attempt to apply to Huawei, fail, and then will go back and remove those again. So for a short time, this new VRF should be present, should be available. Let's have a look if that is true. Yeah, we can see ABCD2, that's the new VRF that we've configured. It just became available on XE. Let's see on XR if it is available. Yep, so the new VRF is now existing on XR. And so we're gonna error out here, no configuration change on the Huawei router. And still there on XE. Let's see what happens here. All right, it's been removed already. So what has happened is that when it tried to configure the Huawei device, it failed. And since it's part of a transaction, all or nothing, it went back to the devices, to the XE and the XR device, and rolled it back to the previous state. In the feedback from the device, or from UniConfig, we see what the failure message is on the Huawei device, and we learned that the rollback status was completed. So it successfully rolled back to the exact previous state before that transaction was done. So we have reversed that mistake. We've kind of made it AS100, and all the 3 devices pass. They are completed. So that's the proof that after removing the mistake, it works. Here we want to remove a layer 3 VPN BGP instance. So we're going to go in and remove it from the intent config data store. I'm going to execute all these different snippets in OpenConfig. We have a look at the delta, or the diff that we're going to apply, and we see all these undo statements here for the Huawei device, or these no commands for the Cisco device. And at this point, I should say that in the readers and writers that we implement for each device, for CLI units, for example, in the readers, you will find the capabilities to read configuration and convert to OpenConfig. And then in the writer part, you'll find the update, the delete, and the write, or the create, the update, and the delete. So we have, methods for getting the configuration on and getting the configuration off again of the device. So that could be a simple no statement, but in some cases, it's really important to have the sequence right. In some cases, it's not a simple no statement. It's a little bit trickier. It's important to get the access list removed in a certain sequence from the interface and so on. So all this good stuff is taken care of. All right, and here we're gonna remove another instance. Layer 3 VPN instance. So again, we're gonna prepare the changes that we want to make to the network in the config data store. So we kind of stage those changes. We convince ourselves that those are in fact the changes we want to make by looking at the diff that shows us exactly what is being changed in the network. Then that is being shown on an OpenConfig level. And then if we want to see exactly what's happening in the network, we can, again, execute the dry run to show the CLI impact. All right, so we removed that other VRF, or layer 3 VPN BGP instance from the config data store. Well, we are done. We look at the diffs and we commit. All right. And the next step, we'll see. So this shows us in real time what's happening in the network, how these things are being removed in netconf and in CLI. This is the Huawei device. All right, so we are down to the basic BGP configuration where we started on Huawei. Here we are down to the basic BGP, global BGP config on XE and XR. We get a complete from all the 3 steps of that transaction. Now we go in and manually remove the global BGP statement and have a look at the reconciliation capabilities. So we load the current device configuration. So we look at the current device configuration. It has BGP in there. Now what we're going to do is we're going to go in there and manually remove that on the device. Remove the global BGP configuration on the device. What we are doing here now is we sync from the device, from the iOS device, and we see the changes, the delta here. So we see exactly what's no longer on the device and what's on the data store and what's no longer on the device. So we see that diff. We see exactly, if we want to commit now, we see exactly what what has been added or what will be added or deleted. So if we would kind of apply, we would be able to kind of get that configuration back if we wanted to. So you see that we've kind of recreated the global BGP configuration here. And here we have finally removed all the BGP configuration. All right, that concludes the demo. Hope that was useful, and check us out on FRINX.io. Bye.